in the last lesson of this first unit test for Unit 2, or Lesson 2.4, Day 2. The main focus of this lesson is to solve polynomial equations, and really what we're doing is just kind of adding some tools to help you figure out how do you solve if I take away your graphing calculator. Okay, let's start with just a warm-up. We did one of these last week. We're just trying to come up with an equation, and these are our solutions. So if we've got x is equal to -3, that comes from x plus 3. And we've got x equals 2/3. We could either leave it in that form, or if you don't want to leave it in that form, we could change it to 3x minus 2. So if we're trying to come up with an equation, we're just going to multiply those out. Now, here's the last piece. It says the coefficient has to be a coefficient of 1. So we need this to be a 1. We're going to divide everything through by 3. So we get x squared plus 7/3 x minus 2. Now, if I wouldn't have written this out in this format, but I could have just done x plus 3 and x plus 2/3, minus 2/3, I should end up with the same thing that I got here. So again, just trying to show you some options. If we chose it to do it this way, we have x squared minus 2/3 x plus 3x minus 2. And notice in here, 3/3 is equal to 9/3. When you add those, you do get the positive 7/3. So again, whichever one is easier for you. Okay. The rational zeros theorem says if for all of the real zeros that are either rational or irrational, they would still show up on your graph. So let's go ahead and solve both of these. I have my first one entered already. And I'm going to go ahead and graph it. Okay, so when I graph it, it looks like the following. It looks as though there's two irrational, but one of them is rational. It looks like it's -2. So I'm going to go into that table, and I can quickly see that it is -2. Now, to find the other two, without just doing calc intercepts, we can go ahead and synthetically divide. So we're going to go synthetically divide by -2. I'm going to pause it and let you take a moment to synthetically divide. So when I went and did synthetic division, I ended up with the following polynomial equation. When I set that equal to 0 and solve, we end up with plus or minus radical 10. So our solutions are -2 plus or minus radical 10. And if I wanted to check those, I could go see what the equivalent decimal is for radical 10 and then just confirm those that I've got. This would be a positive radical 10 and this would be a negative radical 10. And if I go check the square root of 10, I get 3.1. And if you look at both of those intercepts, they look approximately the same. Alright, let's go do the second one. Again, I'm going to go ahead and graph it and see what zeros I have. Okay, so if I go look at my graph, I know there's supposed to be 3 solutions, but it looks as though there's only one rational, and when I go and find that, I end up with x is 0.258, and then the other two, because they don't hit the x-axis, that must mean there are 2 imaginary solutions, and we will actually get to those in unit or lesson 2.5. Okay, next. This is one of those, as I said, kind of tricks or tools that can help you figure out if you were totally stuck without a graphing calculator, how could you find some of those solutions? It's called the upper and lower bounds test. It says if k, which is a possible solution, is an upper bound, then when we synthetically divide, every number in that last line is non-negative. So that means it could be positive or it could be 0. Let me show you what we're talking about. So we're going to go and check 5, and we're going to go ahead and synthetically divide. And again, I'm just going to pause it when you go and do the synthetic division. Okay, so When I went and checked 5, what I'm trying to point out is every number in this last line is non-negative. So what that means, there are no solutions that are greater than 5. And let me just reinforce with the graph. I went and I graphed it. If you notice, the largest solution is 4, which confirms there is no numbers that are solutions greater than 5. So it doesn't tell you exactly, but at least tells you don't look at any numbers that are greater than 5. So again, if I was given this whole thing on my own, and remember I had to go and make a list of those P's and Q's, well, if you take a look, some of those P's over Q's would be plus or minus 8 over plus or minus 1. So this just simply lets me know, don't even bother checking to see if 8 is a solution, because I know it's not using that upper bound. Now on the flip side, it says we can go use a lower bound. And let's read through this. This says the numbers in the last line have to alternate non-negative and non-positive. Again, let's go ahead and do it. I'm going to pause. We'll use synthetically divided. Okay, so again, I went synthetically divided. Take a look. When it is a lower bound, it's alternating between non-negative, which this is non-negative, and then non-positive. Now, you might be saying, well, where does 0 fall? 0 would fall into either one of these, because 0 is non-negative, and it is also non-positive. So if this was a 0, that would still count as well. And again, just to reinforce from that graph, here's my graph. We're saying that there are no solutions that are less than negative 2. And here's negative 2, and if you take a look, we've got a solution somewhere between negative 1 and 2, and the solution somewhere around 1/2. So again, relating it back to those P's and Q's, if you can envision, I would have a negative 8 in there, I would have a negative 4 in there as well as possible roots. But again, what this is saying is, don't bother checking those, because the smallest solution that you have is negative 2. As I said, these are just simply tools to take you from the entire list of P's over Q's and trying to cut it down. Okay. So let's go take a look at this next one. They want us to solve from just the standard window. So I'm going to pause, go ahead and get this entered in my calculator. Okay, so I've got my standard window. I just hit zoom standard. There's my equation. I can tell from the exponent there should be 3 solutions. But again, trying to force you not to use your graphing calculator entirely. It looks as though negative 1 and 2 are solutions. I'm going to go into the table and confirm that. There's negative 1 and there's positive 2. Those are 2 solutions. I need to go find that third one by hand. So I'm writing myself a note. I've got x is negative 1. I also have x is equal to 2. So we're going to start by synthetically dividing, and it doesn't matter which one. I'm going to synthetically divide by negative 1 to begin with. We've got 1. This would be 40. Negative 40 is 0. Okay? Now what I'm going to do is I'm going to take that, I'm going to synthetically divide by 2, because right now this is still a quadratic. Maybe I can factor it, maybe I can't, but let's use synthetic division. Okay, so if you can see, when I synthetically divide again, I have x minus 20 as a factor, so when I set that equal to 0, I get x is equal to 20. So we end up with solutions of negative 1, 2, and 20. Again, keeping in mind the ultimate goal is to solve, that if we restrict you in any way by not letting you use your graphing calculator, you can type in or synthetically divide by the solutions that you've been given. Okay, last piece in this lesson is long division. And we want to start by just remembering, how do we long divide with numbers? I'm taking 15 divided by 4, that's 3. I multiply, and then I subtract, I start the process again. 32 divided by 4 is 8. I multiply, I subtract, and then I bring down. ways that we can write this. One is called the summary statement form. So if this was the problem, we would write this as 4 times 381 plus that remainder of 1. And when I check it, it should work out. If I go write it in fraction form, I've got 381 plus my remainder of 1 over my divisor, which was 4. And again, if you check that, you would get 381 and 1/4. 4 times 381 plus 1 gets you back to what we started with. So just trying to show you how does it work from a numerical standpoint before we look at the polynomials. Okay, let's start off with one that's a little bit easier. So we've got x minus 2. So remember what we start with, we want to divide. I'm doing x squared divided by x, that's x. You want to make sure your like terms line up. Our next step is we multiply. If we look at our next step, we subtract. Well, the x squareds cancel out. -5 minus a -2 is actually a plus 2x. That should be 3. And then I bring down. And I start the process again. -3x divided by x would be a -3. I multiply. I subtract. 1 minus 6 is a -5. So writing it in that fraction form, we would have our answer is x minus 3 plus a -5 over x minus 2. Here's the quotient, here's the remainder, here's the divisor. Alright, let's move on to the next one. The only other thing I'm confirming, I'm going down in decreasing order. If I wasn't, I would have to rewrite, or if there's any missing terms, I would have to fill those in with a 0. Okay, so again, we're going to divide 6x cubed divided by 2x, if you need to see what I'm thinking. That gives me a 3x squared, and again, you want to make sure your like terms are lining up, so I'm putting it on top of the x squared. We multiply. We subtract. And then we bring down and start again. I divide -4x, multiply, and subtract. And then again, 4x divided by 2x is 2. And in this case, we ended up with a remainder of 0. So there's our final answer. Okay, we've got one more, and I just have a little over a minute. So I'm going to pause it, set it up. Okay, here's my setup, and notice I had several zeros that I had to fill in. So we're going to start, we divide, x to the 4th, we multiply. Subtract, and bring down. And again, I'm going to pause just so we don't go over the 15 minute. Okay, give me a minute to take a look at it. Now, one thing you might be asking, first of all, let me finish this up. In that fraction form, I would write this as 2 over x minus 1. You might be asking, could I have done synthetic division? On all of these examples, you could have. The only time you cannot is if you had a larger exponent here. So in other words, you only can use synthetic division when your divisors are linear. You're going to be looking at some tonight where they are not linear, and you would be forced to use long division